Alright guys, this is the beginning of chapter 4. This is 4.1, using graphs to relate two quantities. Okay, so our objective here is to represent mathematical relationships using graphs. Okay, and we're going to see a few different types of graphs. So let's start with the problem. The graph shows the volume of air in a balloon as you blow it up until it pops. What are the variables? Describe how the variables are related at various points on the graph. Well, if we look at this graph, our two variables will always be the x and the y-axis. So, the air in the balloon, here's one variable, which is the volume, and here's the other variable, which is the time. So, variables are volume and time. Okay? Next part of the question says describe how the variables are related at various points on the graph. Okay? Well, we can say that the volume is 0 at time 0. And as time increases, it seems that volume is going up as well. And then it kind of pauses, and then it goes up again, it pauses, and then it goes up again, pauses, and it goes up finally, and then it goes all the way back down. So the volume goes from a very high point to a very low point, okay? So we can say volume increases as time increases. Because remember, when you move from left to right on this graph, you are increasing, the numbers are getting larger. Same with volume, you're increasing. So this could be 1, 2, 3. This will be 1, 2, 3, so on and so forth. Okay, so volume increases as time increases, and then volume drops after a certain time. I'm going to put in parentheses when balloon pops. Okay, so this graph makes sense in terms of a balloon. Okay, our balloon is going to continuously increase up into a certain point in time, and then when it pops, its volume goes all the way back down to 0. All right, so our next problem is we're going to match a table and a graph. So a band allowed fans to download its new video from its website. The table shows the total number of downloads after 1, 2, 3, and 4 days. Which graph could represent the data shown in the table? All right, so first let's take a look at this graph, or this table. So on day 1, they had 346 downloads. On day 2, they had 1,011 downloads. On day 3, they had 3,455 downloads. And on day 4, they had 10,426 downloads. So, first thing that we want to do, guys, is find out how much is it increasing by. So to get from 246 to 1,011, okay, we're going to do 1,011 minus 346, okay? We're going to borrow from here. This becomes 0. This will be 11. 11 minus 6 is 5. In order to subtract the 4, we also have to borrow from here. This becomes 0. This becomes 9. This becomes 10. 6. And then 6 again. So 665 was our increase. So we're going to put plus 665. Okay? We're going to do the same here. So 3,455 minus 1,011. Okay? And let's see. We've got 5 minus 1 is 4, 4, 4, 2. So it increased by 2,444. And our last one, 10,426 minus 3,455. This will give us 7. Borrow 0, 9, 13. So then 13 minus 4 is 9. 9 minus 3 is 6. So then plus 6,971. Now, one thing you need to notice, guys, our days are increasing by 1 each time, right? But the total number of downloads is not increasing by the same amount after each day, right? It's increasing. So it increased by 665 between day 1 and 2, 2,444 between 2 and 3, and then between 3 and 4, it increased 6,971. So not only is it increasing, but the amount that it's increasing is also going up, okay? So the reason, first off, we can eliminate D. Why can we eliminate D? Because D is actually going down. So as the days increase, it's saying that the total number of downloads is decreasing. Notice how it's going down the graph. We're moving down, okay? So this one's not it. So we're between A, C, and B. C is saying that as the days increase, your increase is decreasing. So like you're not, it would kind of be this in reverse. So if we were increasing by 6,971, then going down, like increasing, but by a smaller number, like 2,444. And then if we went and increased by 665, that's even lower. That would look more like C, but so C is not our answer, okay? A is a linear, right? So we're going up by the same amount each time. It's straight. So A is also not our answer. So B has to be our answer, okay? And I'm going to explain also why B is our answer. So if we started from day 1, right, we had 346. That would be down here at this point. As we increase our days, right, these are constant. So these are increasing by the same amount each time. But notice how the graph is going up by a lot more each time. Its increase is here, then it goes here, and then it gets really steep to go up here, okay? That's exactly what ours was showing, right? Our increase was going drastically higher from 665. We ended with almost 7,000 more downloads between 2 days, between day 3 and day 4. So our increase needs to look like B, where it's going up more drastically as the days go on. Okay, we're going to try another example. So the table shows the amount of sunscreen left in a can based on the number of times the sunscreen has been used. Which graph could represent the data shown in the table? So for sunscreen, we've got the number of uses, 0, 1, 2, and 3, and the amount of sunscreen left in the can. Left in the can. So at 0, we're at 5. All 3 of these start at the number of uses 0 at 5. So that one doesn't eliminate anything. Going from 0 to 1, we go down 0.2. To go from 4.8 to 4.6, we also went down 0.2. And then 4.6 to 4.4, we went down 0.2. Okay, so each time it's going down 0.2. So this is going to be a linear example, okay? That means that it should lie in a line. Now, the number of uses, it didn't get down to 0, so A is not right, okay? It did not go all the way down to 0 by the time we got to 3. B is saying that its decrease is like it's going down by more and more. That's not what we want. And C is pretty much perfect, okay? So it's going down by the same amount each time. It's not really fluctuating that much, and that's exactly what ours is saying. It's going down by negative 0.2, and that's perfect. So C is the right answer. Okay, sketching a graph. So a model rocket rises quickly and then slows to a stop as its fuel burns out. It begins to fall quickly until the parachute opens, after which it falls slowly back to Earth. With what sketch of a graph could represent the height of the rocket during its flight? Label each section. Okay, so this one was already done for us, and we're just going to talk about it. So the height is our y-axis or our vertical axis, and time is our x-axis or the horizontal variable. Okay, so as time increases, this is exactly what the height is doing. So we see by this portion right here, it's rising really quickly. So the rocket is shooting off from the ground, going up, 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 and up. When the fuel burns out at this point is when it stops rising. So it's fuel burned out probably like around here, because it stopped rising at that really, really steep rate. And then it's still going up because it has momentum, but then at some point it stops rising and it starts to fall. Okay, it starts to fall quickly, and then the parachute opens. That's this point right here. When the parachute opens, then it starts to fall slower at a steady rate. Okay, and then by the time it reaches all the way down here, it has made contact back with the ground because its height is 0. Okay, we are going to do one of these on our own. So let's check it out. All right, so suppose you start to swing yourself on a playground swing. You move back and forth and swing higher in the air. When you slowly swing to a stop, what sketch of a graph could represent how your height from the ground might change over time? Label each section. So let's take a swing set. This is a very bad swing set, but you guys get the point. Okay, so here's our swing. And as we're swinging, when you go back, you're going to reach a certain point above that's going to have a height, right? And then as you go forward, you're also going to reach that same point in terms of height. And when you're down at the bottom, right, in the middle of your swing, you're going to be at 0. Okay, so if we were to draw a little chart, we're going to have time, because it's asking a graph that could represent how your height from the ground might change over time. So this is going to be height. So we know our two variables have to be height and time. I'm going to abbreviate it as HT. Now, at 0 time, our height's going to be 0. So we're going to start right here, okay? As time goes on, we're going to start to swing, right? But we're always going to come back down, back to the bottom, right? Because our height's going to be 0. But then we're going to jump right back up, and we're going to swing higher and higher and higher and higher. And then we're going to get to a point where we're not going to swing any higher. So we might be swinging at this height for a little while. It is our maximum height. And then we're like, okay, we're kind of tired now, so let's start slowing down. Let's start swinging back towards the ground. And we're back at the ground. So it's going to look kind of like that. Now, you could have extended the time when you were in the when you were having fun in this area, if you wanted to be in that area for longer, if you're having a really good time. What if you weren't having a good time and you wanted to come out? That could have been shorter. So it all depends on a certain amount of variables. But this is generally what it would look like if you were to graph time versus height in order to find you swinging on a swing set. All right. Here's your check yourself before you wreck yourself. So if you want to pause the video and do these on your own, it's a great practice method. And then you can go over them together if you don't get any of them right. Remember okay? So what are the variables in the graph at the right? Let's answer that question first. We've got fuel used, which is our y-axis or our horizontal variable, and then car weight. Those are our two variables. Use the graph to describe how the variables are related. Well, as the weight of your car increases, so does the fuel used, okay? As the weight of your car increases, your fuel, or you use more fuel. You use more fuel. All right, number 2, describe the relationship between time and temperature in the table below. So time in the number of hours after noon, we've got 1, 3, 5, and 7. And at 1, the temperature is 61. At 3, the temperature is 62. At 5, the temperature is 58. And at 7, the temperature is 51. So the temperature seems to be declining as the time increases. Is going down as the temperature as as the time increases. Okay. All right, match one of the labeled segments in the graph below with each of the following verbal descriptions. It's either rising slowly, it's constant, or it's falling quickly. Well, A is rising, right? But that's rising pretty quickly. So I would label rising slowly as B, okay? Because it's going up, but it's going up slowly. So B is going to be our rising slowly. Okay, our constant is going to be C. Why? Because it's not rising and it's not falling. It's kind of staying the same, okay? So C is going to be our constant. And then our falling quickly is obviously D, okay? It's going down at a very rapid rate. So D is falling quickly. Now, E is also falling, but it's not falling very fast. D is falling much faster. Okay? And then number 4. Describe a real-world relationship that could be represented by the graph sketched above. Well, this is actually very similar to that rocket example, so you could use that one. Because the A portion of the graph represents the rocket going up. B represents when the fuel kind of gave out. C represents when it's like idle in the air, it's like about to fall. D represents when it's falling really, really quickly. So its fuel's given out, it starts to fall really fast. And the E portion represents when the parachute's gone out and it starts to slow down. So this could be our rocket example. If you came up with a better example, good for you. Mine's not very good. Answers are on the next slide. Okay. All right, and then exit ticket. I want you guys to think about, could you have a graph with 3 variables? Why or why not? I'm not going to go over this one. I want you guys just to think about it. It's a good little example just to get your mind thinking. So think about, could you have a graph with 3 variables? All right, here's your homework. Good luck.